A century ago, someone named Einstein proposed two theories of relativity that would impact the astronomy world forever. Or at least up to now. I can't really predict the future. The first theory was on special relativity. This theory states that the speed of stuff can change, unless it's light, since you can't increase the speed of light. The more you speed up an object, the more mass it will contain, and when it reaches the speed of light, it will have infinite mass. Also, due to the speed increase, time for the moving objects will change as well. The faster moving objects will experience time normally, while everything else outside is faster. So basically, you or the object that is traveling at the speed of light will be going into the future. But what happens when you take this theory with more massive and large objects? That's where Einstein's theory of general relativity comes in. It states that objects with more mass have an attractive force, which is also known as gravity. But that's something you should already know, since that's what's keeping us on Earth, and the Earth in orbit around the Sun, and our solar system in orbit around the black hole at the center of the Milky Way, and I don't really think anything comes after that, but I think you get the point. But what you probably didn't know, unless you did, is that objects with more mass are able to curve space-time and light. What's the proof of this? Gravitational lensing in black holes. Gravitational lensing is when light gets bent from a massive object such as a planet or a star. We can see this a bit with the Hubble Space Telescope and how Abell 520 appears 3 different times at 3 different times since it's behind some dark matter. With black holes, not only do you have extreme gravitational lensing, but you also get a noticeable time dilation as well. So by going into the black hole, you'd be going forward in time at a faster rate because of the mass of the black hole. If an immortal person were to be observing you going into the black hole, they would notice you going slower until you faded into darkness millions of years later with a redshift. So what is there to take from this? Traveling at extremely fast speeds can change the way you perceive time according to the theory of special relativity, and traveling near supermassive objects can also do the same thing according to the theory of general relativity. So is Einstein wrong? As far as we know now, no. There's a very high chance I may have misinterpreted some things in the video, so please check my sources in the description and feel free to correct stuff in the comments. I don't know how to end this video in a clever and cohesive way, so bye.